What you are about to witness is not survival. It is a masterclass in primitive engineering. One man, armed with only basic tools and a profound understanding of physics, will transform this unforgiving wilderness. He will build structures that defy modern conventions. Pay close attention. The techniques you see here, forgotten by time, will change how you view construction. He isn't just gathering wood. He is selecting for specific combustion properties and tinder quality. The first principle of any project, securing the site. This requires clearing and preparing a stable work area. With the site prepared, he establishes a safe and controlled fire pit. He's not just stacking kindling, he's building a self-ventilating structure to maximize airflow for ignition. Success, the controlled burn, is the first victory, providing warmth, security, and the means to process materials. Now he constructs a stone reflector wall. This isn't for decoration. It's a passive heating system, absorbing thermal energy and radiating it back into the living space. The intensity of the fire, contained and directed, transforms this simple cave into a viable shelter. The local geology provides the primary building material, sedimentary stone, easily split into flat, usable slabs. He's assessing the stability of this rock overhang, a potential natural roof for a more complex structure. This is a geological survey in its most basic form. He is testing the substrate for load-bearing capacity. The excavation starts. He is leveling the ground to create a stable foundation for what's to come. Each swing of the pickaxe is a calculated effort to shape the earth to his will. The project is expanding. He is no longer just surviving. He is establishing a foothold. Transporting processed timber to the site. Efficiency of movement is key when working alone. The felling of small trees. He selects young, straight lumber, easy to work with and strong for its weight. Now, the assembly of the primary frame. He's lashing the beams together, creating the skeleton of the structure. Inside the cave, he begins crafting precision components. Notice the notching technique. This is mortise and tenon joinery, a timeless technique that requires no metal fasteners. He's using a hand-powered auger to drill pilot holes for the wooden dowels that will lock the joints. The frame is being raised inside the cave, using the rock itself as a back wall. Each dowel is hand-carved to ensure a friction-tight fit, the primitive equivalent of a bolt. The flooring comes next. A series of bamboo joists creates a level surface, elevated from the damp cave floor. Now for the walls, he begins preparing a clay and soil mixture. This isn't just mud, it's daub, a composite material used for millennia as insulation and sealant. A moment of rest. The structure is taking shape, a testament to his methodical planning. The bamboo lattice for the inner walls is being prepared, creating the wattle for the daub. The lattice is carefully installed, providing the necessary tensile strength for the mud walls. The application of the daub is a slow, deliberate process, ensuring a solid, seamless wall. He inspects his work. The symmetry and finish are remarkable for the tools at hand. Final touches on the wall. The smooth finish will reduce cracking as the clay dries and cures. The finished hut, a thermally efficient, secure, and dry shelter, built entirely from the surrounding environment. A new project begins. The precision of this initial joint indicates a more complex structure. He's erecting a new framework, this time in a more exposed cave opening. The horizontal beams are interlocked, creating a grid that will form the subfloor and walls. He backfills around the foundation posts, using the earth itself to anchor the structure firmly in place. A survey of the wider area. A successful engineer always maintains awareness of their resource availability. The structure stands partially complete, a skeleton awaiting its skin. He uses natural fiber cordage, likely processed from tree bark or vines for lashing. The walls are being infilled with bamboo, a material with a phenomenal strength-to-weight ratio. An incredible detail, he's carving out a functional window, complete with a sliding shutter mechanism. Further reinforcement of the foundation with stone and earth. The exterior walls are being weatherproofed with a mix of stone and clay. The result is a sturdy, well-insulated structure, seamlessly integrated into the natural cave. The flooring is meticulously laid, each piece of split bamboo fitted perfectly. He fabricates a door, complete with wooden hinges and a latch system. The final floorboards are laid, completing the interior living space. The door is hung and tested for a smooth, functional swing. A close-up of the finished window, a masterpiece of primitive craftsmanship. The work never stops. He immediately begins sourcing timber for the next phase. He's planing the wood with a machete, creating a flat, stable surface for joinery. The amount of material processing required is immense, a true test of endurance. Here's a moment of pure genius. He is hollowing out a large log. This log will become the core of a self-insulating stove, a critical piece of technology. He lines the hollowed log with wet clay. This is the crucial step. The clay will fire into a ceramic shell, protecting the outer wood from combustion. Simultaneously, he constructs the housing for the stove, using the same mortise and tenon technique. A bamboo subfloor is laid for the stove platform, providing elevation and stability. The stove platform is completed, ready to receive the ceramic-lined log. The framework for the hut's walls goes up around the central stove platform. Observe the precision of the joinery. Each piece is custom fit to its neighbor. The hut is taking shape, designed entirely around its heating and cooking core. The initial curing fire. This slow burn will harden the clay liner into a durable ceramic. While the ceramic cures, he forages for more resources. No time is wasted. He identifies a fallen log, already seasoned and ready for processing. Using a handsaw, he bucks the log into manageable sections for transport. Back at the workshop, he splits the logs into usable lumber for the hut's walls. The hand auger is used again, preparing for the dowel-locked joinery. A wooden mallet drives the dowel home, creating a powerful, lasting bond. He harvests bark, which can be processed into cordage or used as a waterproofing membrane. Every part of the natural resource is considered and utilized. The level of detailed craftsmanship is astounding. Now, an entirely new engineering challenge, bridging a gap in the terrain. He secures the main support girders, using the trees as natural bridge pylons. He transports smaller timbers, which will serve as the bridge's decking. The deck beams are laid across the primary girders. He secures the decking with hand-carved wooden pegs, preventing any lateral shifting. He meticulously arranges the deck, ensuring a stable and even surface. Bamboo is brought in for the handrails and final decking layer. He employs a series of friction knots and lashings to bind the bamboo framework. The bamboo decking adds a flexible, high-traction surface to the bridge. Each component is custom trimmed on-site for a perfect fit. The handsaw is indispensable, allowing for clean, precise cuts. The handrail supports are erected and lashed into place. This creates a structure that is not only functional, but also safe. The completed bridge, a triumph of simple machines and structural principles. But the work is not done. He begins preparing for his most ambitious project yet. He's creating wood shavings or feathers, likely for use as fire tinder or as a binder in his clay mixtures. This is fascinating. He's packing the shavings into a plastic bag. This could be for waterproofing or creating a buoyant object. The repetition shows the sheer volume of material required for the next phase. His final creation begins, a treehouse. He's building the foundation platform high in the canopy. The platform is lashed directly to the tree, integrating the structure with the living organism. Again, he uses the hand auger, this time to create joints for the treehouse's circular frame. The circular design is an engineering marvel. It distributes wind load evenly and provides superior structural integrity. He bends green wood to form the main hoops of the roof structure. The hoops are then bound, holding their shape as they season and dry. The skeletal frame is complete, a beautiful and complex piece of organic architecture. The roof rafters are meticulously installed, creating a conical shape that will shed rain effectively. Each rafter is lashed securely to the central compression ring at the apex. A view from below reveals the perfect symmetry of the roof's framework. It's a self-supporting reciprocal roof, an advanced engineering concept. The strength of this design is immense, yet it uses a minimum of materials. He works with a gymnast's balance, high above the forest floor. The final framework pieces are secured, making the structure incredibly rigid. A moment of satisfaction inside the completed frame. The space is functional and inspiring. But the work continues. The structure still needs its skin and final amenities. He now harvests large leaves, the natural equivalent of roofing shingles. Back in the treehouse, he begins the thatching process, layering the leaves to create a waterproof barrier. The thatching begins at the bottom and works up, ensuring each layer overlaps the one below it. The conical roof is now clearly visible, an iconic shape in primitive architecture. He adds a secondary layer of branches over the thatch to protect it from wind uplift. This outer grid compresses the leaves, enhancing their waterproofing ability. The completed roof, a perfect blend of material science and architectural design. The detail on the thatch is incredible, a seamless and beautiful surface. The final touches are applied to the roof cap, sealing the apex against the elements. Now, for an interior feature, he collects stones for a hearth. He lays a stone foundation inside the treehouse for a raised stove. He mixes a new batch of clay, this time for mortar and for the stove body. The clay has been carefully processed to achieve the right plasticity for construction. He begins building the stove walls, using the clay as mortar to bind the stones. This raised hearth is safer and more efficient than a ground fire, especially in a wooden structure. The structure is solid, designed to contain the heat and direct it upwards. He smooths the clay, creating a durable, fire-resistant surface. Flat stones are added on top, which will serve as a cooking surface. The finished stove, a compact, efficient, and safe heating and cooking appliance. He even adds integrated compartments for storing tinder or warming food. A final inspection before the first firing. The top cooking surface is perfectly leveled and sealed. The engineer returns to his masterpiece, carrying materials for the final details. The journey through his domain showcases the scale of his endeavor. He ascends to his workshop in the sky. Inside, he continues to work, crafting the final interior components. A detail of the exterior shows a bamboo downspout for rainwater collection, a truly sustainable design. He applies a final layer of clay to the interior walls for added insulation and a smooth finish. He collects a final batch of thatching leaves, perhaps for interior bedding or insulation. The first fire in the treehouse stove. The space is now truly alive. The fire burns cleanly, proof of a well-designed flue and ventilation system. He's now foraging, not for materials, but for food, using his knowledge of the local ecosystem. He unearths edible tubers, a reliable source of carbohydrates. The engineer is also a hunter. He sets a simple but effective deadfall trap. The trigger mechanism is sensitive, a marvel of mechanical simplicity. The trap is set, a passive method of acquiring protein while he works. Work on the treehouse continues, adding the final wall panels. The roof is given a final layer of thatch to ensure it is completely weatherproof. He meticulously weaves the final exterior wall panels. A bamboo window frame is installed, providing light and a view of his domain. The structure is now fully enclosed, a secure sanctuary in the canopy. The final shot of the completed treehouse, a true work of art and engineering. He fabricates the door, the final piece of the architectural puzzle. The hand auger is essential for creating the pivot points for a simple hinge. The interior floor is completed, a comfortable and durable surface. This appears to be a flexible screen or mat, woven from bamboo and cordage. The scale of this woven panel suggests it could be a sleeping mat or a large window covering. The panel is installed, serving as a functional, roll-up wall section. This woven fan, left behind, is a signature of the artist engineer. He didn't conquer the wilderness, he partnered with it. A monument to human ingenuity, patience, and a profound respect for the natural world. A very special thank you to the owner of the YouTube channel Bushcraft Ideas for creating this wonderful video and allowing me to comment. If you enjoyed this narrative, please visit and support their channel at the link in the description below.